completed the operators, behavioral model and all. So, sir need to start the tasks and functions. So, we'll see the tasks and functions, okay? So, actually, what is task and what is a function? So, before going to that, what is task and what is function, let's try to do one thing. So, not an issue. We'll go that in a flow. September, right?
Hello?
Yeah, hello? 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 So, let's start. What is task and function? And so, let's go the thing. Task or function is a piece of code. First of all, let's do this task. Task is a piece of code where we use it for reusability. Reusability. So what is this reusability? So what is the use of reusable nature here? Means, so if I want to use a code multiple times, the same code multiple times, then what I'll do is I'll write that inside task or a function, and then I'll call that function or a task inside my procedural block. So that is what reusability means. So if I want repeat a code for multiple times, then I put that code in a task, or for the matter I put that in the function as well. Put that in task, and then I'll call that, and I will call that wherever I want. So the thing is like, so as we are in the Verilog, our first question, every time one question need to be pop out in our mind. That question is task synthesizable? Because what is meant by synthesizable? Have you gone through this word synthesizable? Have you gone through this word synthesizable? Have you gone through this word synthesizable? Okay. Synthesizable. Synthesizable in the sense, means the code is going to convert into a gate. So any code that is going to convert into a gate, those are called synthesizable codes. So my first question is task synthesizable? To know this question, I need to know one more thing. first thing is like, first understand the prototype. So whenever, because we are doing RTL coding, this is a Verilog in the sense we are doing the design files. So what is the importance of design? Because at the end of the day, my design will going to convert it into IC. So that means whatever the code that are synthesizable, that only I need to put in the RTL. Even Verilog allows to put this non-synthesizable code also in the RTL. But the thing is like, it is very important for us to make sure that that particular piece of code, we'll need to convert it into gate. For example, let's take like this. Example, a sum is equal to a and a XOR b. So now after synthesizing, the code will look like this. So it will look like this. So here, my code, whatever the code I wrote, it got converted into a gate. At the end of the day, it got converted into a gate. So it got converted into a gate. So the thing is like,
अरे चुप हो जाओ रे,
does this have
ये गेट बंद कर दो मेरा.
any equivalent gate representation? Equivalent gate representation. Does #5 has any equivalent gate representation?
No, sir.
Sorry, can you repeat?
No,
right?
no, sir.
No, right? Yeah. Why? Because I can't able to represent #5 in any one of the gates. Because that is a delay. Delay in the sense, if you observe in the pure respective hardware itself, I can't able to say what is delay also. Because if you talk with respect to hardware, it is like I just got the data, based on that data I gave the output. But with our perspective, what it delays means, till you got the data and you give the output, whatever the time you consume, that is called delay. So I can't able to represent what is the time in terms of gates. So #5 is not synthesizable. The similar kind of thing is my task synthesizable. Means there is two answers for this. We will see that what are the two answers. The two answers are yes and no. Actually, task is one of the kind of important concept, and one of the very easiest concept. We will just try to learn with the fingertips. Actually, that's easy, and that's the beauty of the task as well. So let's see how it will look like. Task is a, first of all, task is a system Verilog keyword, okay, and system Verilog keyword as well, okay. Task, and then task name, input arguments, output arguments. So n task, input arguments, inputs, comma, outputs, and then here we need to write begin, end. Inside that we need to write statements. So this is what prototype means. And task calling. Task calling means it's simple like task name, input comma outputs, variables. I need to pass variables, inputs comma outputs. So here, what is this? What is going to convert it into gate? How this task is going to convert into gate is, whatever the statements we are writing inside here, that will actually going to convert it into gate. So my question, again I am asking the same question to me, I am asking the same question to myself, that whether this task is synthesizable or not. Because I came to know that, okay, I can replicate the kind of things, I can replicate whatever the piece of code that has written here multiple times, I can replicate, so I can make it reusability. But to use that inside an RTL, it must be an synthesizable one. So if it must be a synthesizable one, then only I can use it. Or else, even though if I can't, if I use it, at the end of the day, it won't synthesize at all. That means it won't convert it into gate at all. So for that matter, I need to ask one more thing, like, is task synthesizable? So for this, what I will do is, if statements where inside task are synthesizable, then tasks are going to synthesize. Else not synthesizable. Got it? So the thing is like, if statements inside the task I am writing, whatever the statements that are inside the task I am writing, if that are synthesizable, then my task is synthesizable. If the statements that I am going to write inside my task are non-synthesizable, that means if I write hash 5 statements or hash 10 at the rate posage clock or something like that, weight of some a is equal to 1, these kind of statements if I put in it, those are non-synthesizable, because those statements there is no equivalent gate for that. So for that matter, what we will do, those statements are not synthesizable. So whenever you are writing task inside RTL, that means inside design, we need to keep in mind that never put any kind of delay statements inside task. Whenever we are writing any statements inside RTL or design, RTL in the sense design, never put any delay statements. So let's see one example. So what is, so my I got an answer like, is task synthesizable? So for this question, I got an answer like, yes, task is synthesizable if and only if I put synthesize the statements on task. If task is not synthesizable, when if I put any kind of delay statements in the task. So this is what the question this is what the answer I got for my question. So next thing is like, what is the difference between task and function? What is the difference between task and function? Next question. So difference is like, function won't allow any kinds of delays in it. Tasks allow, 1 minute. Guys, okay.
नहीं अब ये चैनल है, दिवाली बाद में चालू हो जाएगा, अपने गटर बंद करवा देंगे, गटर भूख देंगे, फिर चालू हो जाएगा। गड्ढा खोदना पड़ेगा खुद। हाँ, पानी वाला ना गटर वाला नीचे आपका यहाँ। हाँ हाँ, बाहर सही है। हाँ बाहर ये नाले का है तो आपका इस पे हमारे भी उसी नाले पर वो तोड़ के ये बनाएंगे फिर। अच्छा ये तोड़ेंगे
नहीं जाओ खाना देखे जाओ
तो ये बनाएंगे।
नहीं जाओ
अच्छा है ना?
रोटी खाओगे
आज नहीं कम बनाई थी सही है ना? आजा 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 मैं जाऊँ अभी मैं थोड़ी देर में आप फ्री होगी ना? आजा मैं थोड़ी देर लेटूंगी। लेट जाना वो तो भी मेरे लिए रात की 10 होगी देखिए मैं तो ज़्यादा देखिए धीरे से मुझे क्या दिक्कत है ये भी तेरे पास पैसा जब देखिए एनर्जी के लिए तो मुझे को भी उसके लिए उसकी खाली ये क्या करेगी
This conference will now be recorded.
So, whatever other trainer Sainath was telling, please ignore. I mean, why I'm saying ignore is, he was thinking that he was doing for a different batch. Because he spoke to Chetan, Chetan was supposed to do the batch, and he was assuming that somewhere in between the course is there, so he started with task and function. I think that's what he was talking about, right, in the session. Okay, so now I got the context. Are you all familiar with how to use GVim? Has a session been done on how to use GVim? So you're all clear with the shortcuts. And have you done any work where you have practiced some GVim commands and other things? Okay, fine. Do you know what is indentation? Yeah, indentation is nothing but, I'll show you one example. This could be an example of indentation where I have a function. I will not code everything like this. If I'm coding something inside a begin end, I would give a space. For example, here, I'm giving a space, one tab space, so that the code looks easy to read. There are some guidelines on how indentation should be done. Why I'm doing this revision is so that you have continuity with what I'm going to teach. Indentation is basically keeping a group of lines with a fixed tab space. How to identify a group? All the lines inside begin and end makes a group. So I have a piece of code which starts with begin and end. Here I have begin, here I have end, for example. Anything below it should be spaced with one tab space. Here also, let's say I have begin. So they should not be like this. You should keep like this. And again, here you should not have variable spaces like this. This is not user friendly, I mean, not easy to read. Okay. Rather, having everything with a uniform space is this is called as the tab space. I can even set the tab stop equal to, let's say, 2. So each tab will only mean 2 spaces. If I want to, standard we use is 4. We can even go with 8. Everything will be shifted by 8 spaces. So general standard would be to go with. Now, whole group can be shifted by one tab space by using virtual block concept in GVim. You know, in GVim, there is a concept of visual blocks, not virtual, visual block. Using that, you can shift the entire block. And you can use set tab stop to set the number of spaces in tab. I think rest of the things we can discuss as we go forward. Okay. I think the earlier the trainer has given you overview of how model sim is used. Okay. First of all, do you all know what is model sim? Why we use model sim? Simulation. Okay. So what exactly is simulation? Let's try to understand. You see, for last 1 month, you have learned digital design. During that time, you have implemented some frequency dividers, frequency multipliers, some combinational logic, multiple things you have implemented. Let's say you have come up with some circuit. What is the guarantee that it works? It is correct circuit. I'll show you one example. This is an example of a 3-bit up counter. Assume this is an example of a 3-bit up counter. Okay, I will tell you that these 3 AND gates, these inverters, this OR gate, XOR gate, NOT gate, and 3 flip-flops put together makes a 3-bit up counter. How do I confirm that this actually behaves like a 3-bit up counter? That is where comes the concept of a simulation. So what I do as part of the simulation is, I will take this circuit, I will develop a Verilog code using this behavior. Going forward, we will call that kind of model coding is called as structural modeling style. I'll explain you today itself what exactly is structural modeling. In structural modeling, we develop the code which is similar to this one. Then once you have developed the code, how do you prove that that code is actually working? We run this simulation. To run the simulation, we apply inputs. I will again give you an example to understand what is simulation. Let's say I have developed an AND gate. And some logic, right? So what exactly is a simulation is? This is my design. I'm trying to verify. We apply some inputs to it. We get the outputs. We check whether these outputs coming as per our expectation. So let's probably AND gate is not a good example. You take any design for that matter. I was showing you an example of up counter. This up counter, I will develop the Verilog code. Then to that Verilog code, I will give clock and reset as inputs. I will check whether my count comes in this pattern of 0, 1, 2, 3, so on. Based on that, we confirm that this circuit is correct. If anytime I see that this behavior is not coming, then that means what? Somewhere things have gone wrong. Either you have used a wrong gate, either you have used some connection is missing. So to prove that whatever code you have developed or whatever circuit you have developed, we use the concept of simulation. Why simulation is important? Why do we need to do simulation? Because once you have developed this circuit, this will go into a chip. If this is not behaving properly, if it is not behaving like an up counter, it is behaving some other manner, then will my chip work fine? No. The same chip will go into my final product. Will it work properly? So simulation is a way of verifying the Verilog code you have developed. What do you do as part of simulation? Let's try to understand. What we do as part of simulation. we use a simulation tool which will generate the inputs and as per your user requirement. And it applies those inputs are applied to the design. When you apply inputs, what will come? Design will give the outputs. Based on that output, we check the outputs, confirm if design is working. There are various types of simulators. Model sim, Questa sim, VCS, NC sim. So the model sim, Questa sim are from Siemens. Earlier it used to be Mentor Graphics. VCS is from Synopsys. NC sim is from Cadence. Then there is some Rivera, some tools are there. There is one more company. Okay, forgot the name of the company. But anyway, this is not very important for now. All these tools does the same thing. These are like, in a simple analogy, these are like all are bikes of different brands. Okay. One could be a TVS brand, one could be Bajaj brand, one could be Hero brand. It's like once you know how to ride a bike, other bike you can learn in a day. Same is the concept. So you should not be too much worried about which tool am I using. I mean, am I learning model sim? Am I learning VCS? You don't need to worry because all the tools have lot of things in common. What do we do typically as part of a simulation? Let's try to understand. When you run a simulation, what do we do? So what all steps are involved in simulation flow? I think other trainer might have given you idea what is that is done. First thing we do is create a library. That is Verilog. Then what do we do? We compile the files. It can be Verilog. Right now it's only Verilog. Let me not bring in system Verilog. Let's only talk about Verilog. Tell me, what does compilation do? It checks for errors. Okay. What else it does? Converts the Verilog code into object file. I mean, some design internal understandable form. See that? Sorry, tool understandable form. Now, what exactly is inside object, you don't worry. But object file is a tool specific format. So, which is the command used for this purpose? Verilog. Verilog is the command we use for this purpose. Once you have done the compilation, what is the next thing you do? We do something called as elaboration. Let us understand what is meant by elaboration. I will give you a simple analogy. If I ask you to visualize the institute building, how will you visualize? The building has 4 floors. Each floor has this many rooms. This is the number of chairs in each room. So compilation means, what is compilation in the process? You come to each floor and understand how many rooms are there, what are the facilities in each room. That is called as compilation, kind of. What is elaboration is, whatever you have understood about each room, you connect all the information. Then you have finally the building structure. So how does the overall building looks like? You have made up the complete idea. That process of tool connecting all the information is what we call as the elaboration. Yeah, you got the idea? So it has compiled 5 modules. Let's say module 1, module 2, module 3, module 4, module 4. Finally, it has to come up with the structure. how the entire test bench looks like, entire design looks like. That process is called as elaboration. Elaboration means it is elaborating how the entire structure looks like. So the tool coming up with the total environment structure. Again, elaboration is an internal process. How tool does elaboration is specific to the tool, we don't need to worry about. Once you have done elaboration, you can do the simulation. Elaboration is done using which command? Vsim command. Now you may say it should be simulation, right? But you take it as vsim means elaboration. Then to run the simulation, run execute. Now, is hyphenol compulsory? It is not compulsory. If you say 10 nanosecond means runs for 10 nanosecond duration. Run 100 ns means runs for 100 ns duration. Run all means runs till $finish is called. Now the question comes, what is $finish? What do you think finish should mean? And finish the things, right? So whenever you develop a code, there is a concept in Verilog called as, you can call $finish. What $finish does is, wherever $finish happens, it exits the simulation. Simulation doesn't run further. So run all when you do, it will just wait for $finish to be called. It will not stop at 10 nanosecond. It will not stop at 100 nanosecond. It just continues to run. Till this point, are you clear? So let's revise again. So which is the tool we are going to use? Model sim. When you run with model sim, how many steps do we do? 4 steps at minimum. What is the first one? Library. See, about library, once you have created the library, you don't have to repeat it. It's like one-time work. Let's say you are doing compilation 10 times. Every time you don't need to create the library. But compilation has to be done whenever things are changed. Let's say this room structure is changed. So you, without knowing this, can you give the complete information? No, right? When this room is changed, what should you do? You should come to this room. You should see what are the changes. Then that will become input to the elaboration, right? But library won't change. A library name will be same. Now the question is again, what exactly is library? Why do we need library? Library is required because you have got various object files. When you are compiling, what is the output of a compilation? Object file. When you compile some Verilog code, the output that comes out of Verilog code is the Verilog compilation is the object file. Those object files needs to be stored somewhere. The place we store the object files is called as library. The place where we store the object files is called as library. Is that clear to you? Okay, next. What is elaboration? We have understood. Which command is used for that? Vsim. Then we have understood simulation. For now, this much is required. This much is sufficient. As we go forward, how much we need to know more about tool, we'll discuss. We will divide the next few lectures into 2 parts. I will give a half an hour overview of how the Verilog language has evolved. Because before we start doing anything in Verilog, we need to know why there is a need for Verilog language, right? Other than Verilog, there are so many other languages out there. Which all other languages, you know? C language is there, C++ is there, Python is there, Java is there, .NET is there. With so many languages available, what was the need for a new language called as Verilog? First, we need to understand that. Let's spend some time to understand. So before we go into the presentation, I'll give you a background why the Verilog has evolved. You see, Verilog is a hardware description language. Here stands for what? Hardware, description, language. What does this statement mean? Let's understand it as a plain English. This is the language used for describing the hardware behavior. So Verilog is the language used for describing the hardware behavior. Same thing, I have rephrased it in a different way. Now the question comes, why can't we use C or C++? What is the specific need for a Verilog when we have other languages like C or C++? So let us try to understand. Okay. So to understand that, we need to know how hardware differs from. Do you know that which language can we use C language to develop the software? Yes, right. Anything in the world can be, any software in the world can be implemented in C language. It is the most basic programming language. If that is the case, why can't we use Verilog for defining the hardware? That is where we need to understand how hardware differs from a software. So the first difference is hardware has a structure. Software doesn't have any structure. It is just an executable code. It is just an executable code. Simple example I'll ask. You go to a restaurant. Okay. In restaurant, at the billing counter, what do you see? One machine which he uses for generating the bills, right? If you ask, how does that software looks like? Tell me the structure of a software. Tell me the structure of the billing software that is there. Okay, will you be able to tell that? No, right? Why you can't tell that? Because it is just an executable code. When he runs, it's a piece of code that gets executed. So that software doesn't have any structure. Now, what exactly do I mean by structure? My laptop has a structure. My laptop has a structure. You can define laptop, how it looks like. It has got one USB port. You can tell it has got one SD card port. You can tell it has got a keyboard port. It has got one VGA HDMI port. This concept is what I call as a structure. A software doesn't have anything like a structure. That's the first difference. Second thing is, software executes in 0 time. Software doesn't need any time, because even when you have developed any C program, you don't give any delays. It all gets over in 0 time. Hardware has a concept of time. Software doesn't have any concept. Let's understand line number 34. Hardware has a concept of time means, you take a simple example of a traffic light. You see the traffic light, for first 50 seconds it will be in red. Next 30 seconds it will be in yellow. Next 20 seconds it will be in green. So that hardware is in a state where initially it was in red, then it moved to yellow, then it moved to green. So hardware has a concept of time, concept of state and time, where with state changing with respect to time. State changing with respect to the state changes with respect to the time. Whereas software doesn't have any concept of. The third major difference is hardware has concurrent executing process. Software executes in sequential manner. Let's understand the line number 37. What is line number 37? Hardware has concurrent executing process, whereas software executes in sequential manner. Let's understand the meaning of it. You take a simple example of my laptop, right? In my laptop, there is a presentation is being running. My hardware is running the presentation, right? When I go here, when I change it, the presentation changes. This is happening first thing. Second thing, what is happening? Whatever my laptop image is there, it's coming to display, projector. So the second process is what? Data going from my laptop to the projector. Third, what is happening? People who are sitting somewhere else, due to this online meeting, they are able to listen to my voice. They are able to listen to the audio, video, everything, right? They are able to see that. So, do they run? Are they happening parallelly? Are they running one after other? Parallelly, right? So, what is meant by running parallelly? While I am talking, they are listening. The same data is getting displayed to the projector. Okay, and at the same time, this thing also is changing. Whatever you see here, it is all changing. All of this happening concurrently. Do I have 3 different laptops for that? Or do I have 3 different hardwares for that? All of them are happening where? One single hardware. Okay. I have listed only 3, but there are lot more things that are happening in hardware which we don't know, right? Okay. Which we are ignoring as of now. So in summary, hardware requires a special behavior where it needs to execute multiple concurrent processes. Whereas in software, it doesn't work like that. In software, everything executes in one sequential manner, one line after one. It executes in a first line, second line, third line. It never executes in parallel manner. So this is the 3 differences. This is where the C language is not suitable for hardware purpose. What is mean by that? C language cannot be used to implement the structure. C language doesn't have a concept of state and time. C language doesn't support concurrent executing process. Let us repeat again. So we are now trying to understand why C language cannot be used to implement a hardware. To understand that, we are understanding what are the differences between a hardware and a software. What is the first difference in the hardware? Hardware has a concept of structure. You can see this mobile phone has a structure. What do you mean by mobile phone has a structure? Mobile phone has a port, USB port, SD card port, different ports, which a software doesn't have. How do we get the concept of structure in Verilog? You can tell clock is the port, reset is the port, count is the port. On top of that, you can even tell that it has got an input, it has got an output, everything. Second. What is the second difference? Hardware has a concept of state. I told you example of state, right? Traffic light controller. Right now, currently in green. For next. It changes to yellow. And there for 20 seconds. I'm just giving you an example. This is a particular requirement of hardware which software doesn't have. Next. Hardware has a concept of concurrent executing process which software doesn't need. Because of these three reasons, actually. Because of these three reasons, we need a new language. That is where Verilog is implemented. So what exactly is Verilog? Verilog is C language plus new constructs added to support about three concepts. I mean, not everything in C, part of C language. For example, C language has something called as binary tree. It has got linked list, which a hardware doesn't require. A hardware doesn't require the linked list, binary tree, union, enum, structure. It doesn't require all of them. So then you may say, why are you writing? I'm trying to make you feel comfortable with Verilog. Verilog language is similar to C language in many respects. Plus new constructs. New constructs added to support about three concepts. Which are the three concepts I am talking about? Concept of structure, concept of state and time, concept of concurrent executive. So there are new things that are added. If I have to tell you one thing, Verilog is among the simplest programming languages in the world. Verilog is among the simplest languages to learn. I'll tell you the reason also. Okay. If you take C language, how many things you come across in C? So many things. Operators, data types. Even in data types, what are things you come across? Int, short int, log int, long int, char, struct, union. So many things, right? Verilog, in comparison, has only 4 data types: integer, real, time. That's it. Now, whatever operators that are there in C language, what all operators you might be aware? Arithmetic operators, equality operators, logical operators. They're exactly same in C language, Verilog also. Whatever operators, if you know. Now you may say, I never studied C language. So you don't need to come prepared with them. We will teach everything. Now then why am I comparing this is to tell you that it is simplest language to learn. You don't really have to worry much about Verilog language. As a language, it's very simple. What makes it, what is difficult part of our whole course in Verilog is, we are going to take some designs like FIFO, interrupt controller, SPI controller, few designs we are going to take. So understanding those designs, implementing those designs using Verilog will be the difficult part. Learning Verilog is very easy. How much easy it is if you take one language, let's say Telugu, Kannada, any language you take, it may have thousands of words. Language you take, any language you take, it has got thousands of words, right? You take a dictionary, it will have thousands of words for any language. You know Verilog has how many words? 40 words maximum. 40 to 50 words. Compare it with any other language. Take any other language. Compared to that, Verilog only has 40 to 50 words. What are those words we are talking about? Module, end module, begin, task, function, integer, real, time. Like that you list down, it will come to around 40 to 50 words. These words are what I am calling as constructs. These words is what I am calling as what? Constructs. Verilog language constructs. So big task is a Verilog language construct. Function is a Verilog language construct. Integer is a Verilog language construct. So all you have to do is what? You need to understand what are these 50 words, what is the meaning and how to use these words. Simple, right? It's simple compared to some other language, it's very simple. I think we deviated a little bit. Let's come back to the original topic. So where are we? We are trying to understand how the Verilog language has evolved. So let's go through the presentation. Now that I have given you the background, you will be able to understand this easily. You see, electronics has evolved around 1960s. Design consisted of fewer transistors. If you have between 10 to 100 transistors, it's called as what? SSI. What is that? Small scale integration. If it is 100 to 500, it's called as medium scale. 500 to 20,000, large scale. Anything more than 20,000, very large scale. What exactly are these numbers? What are these? Number of transistors. That means a design which is based on medium scale integration will have anywhere between 100 to 500 transistors. Design with fewer transistors can be manually modeled. Let's say I have only design with 5 transistors. I can manually tell this is the AND gate, this is the drain. Connect this drain to one more transistor gate. Source of this connect to one more transistor. I can manually model this. I can come up with this circuit manually. But as you increase, right now how many transistors did I use in this? 3. When it goes to 20,000 or more, a big number, you cannot manually do this. Is it possible to do this manually? Not possible, right? That is where, however, as the transistor count increases, it becomes difficult to model the design manually. So the current complex designs like mobile phone SoC, the server SoCs requires billions of transistors, which can't be modeled manually. You cannot model them manually. So that is where comes a requirement for automation. You need to automate it. So that is where we come for the solution. So how to automate it? So the solution is what? Implement the design behavior using higher level description language and convert this description to gate level. Understand the design. Implement that using a higher level description. Now the question comes, what is this higher level description? Let's understand what is meant by higher level description. This is the up counter behavioral code, which is also called as higher level description. The same up counter, this is how the code looks when I do it using gates. AND gate, OR gate, XOR gate, 3D flip-flop. You remember that up counter circuit diagram I have shown? This is the low level description. Why it's low level? You're explaining at AND gate, OR gate, XOR gate, D flip-flop. That is why it is called as what? Low level description. At very low level you are telling this AND gate is there. What is description means? If I have to tell you about this building, this is where brick is there. Above this brick, one more brick is there. That would be called as what? Low level description. What will be higher level description? There is a 4 floors. In 4 floors, these many rooms are there. That's all. These rooms are made up of bricks. Now, which brick did you use? What is the size of brick? Which we don't worry. What is low level description means? You start from the explaining at brick level. These many bricks are there. These bricks are arranged in this manner. So, which is easy? Tell me. Explaining at the brick level or floors level? Floors. So that is what is Verilog does for us. Verilog lets me define everything at a top level. Rest of the things, there is a process which will automatically do. So you see both the codes, you see how many files I have opened here? 2 files. One is gate level, one is up counter. Do you see how many files do you see? 2 files you see. I will open both the codes parallelly. Tell me, among the left and right side ones, which is easy to understand? Left one. Why it's easy? It's more like English. Always at the positive edge of the clock, at every positive edge of the clock, if reset is applied, make count equal to 0, else increment count by count plus 1. This could be even easier.
मैंने लड़ाई नहीं करी मैंने इसके पापा की 3 रोटी बनी मैंने आटा मेरा सुबह का 30 मिनट तक निकाल के मैंने से कितना टाइम लगा 10
Very simple. If reset is applied, count equal to 0. Simple example, you go to traffic light, you apply the reset. What will happen to the count? It will become 0, right? When you reset, it will become 0. When you don't do anything, what will happen? The count keeps increasing. That's what it is. This is called as high level description. At high level, you are telling. This is called as low level description, where you are explaining at the gate level. Tell me which one is important. Which one is important? Both are important. Both are important. Then, what is the which one are we going to use for developing purpose? We are going to use it. Then why is it important? Tell me. It is important because this is what actually get manufactured. Your phone doesn't have always code. Your phone doesn't have if-else code. During the whole development process, what they do is, if I am a Verilog designer, a person who is developing the code, I will develop my code in this manner. Then I have got a tool called as synthesis tool. What is the tool does? Synthesis. To that synthesis tool, you give this as an input. This file actually. What is the output? This code. Automatically this code. Let me explain again. High level description is like very much like English. Can you see it's like English? Always at positive edge of clock. If reset applied. Now then you may say, why don't we use English at all? English itself, right? We can write English itself, right? Thing is, my model sim doesn't understand English. My model sim doesn't understand English. It only understands what? Verilog language. Okay. Because the model sim tool is developed to only understand Verilog language or VHDL language. You may say, I will come and go. I will go out and come. My model sim doesn't understand this because it don't know the meaning of what is will means, go means, out means. It doesn't understand. It has got its own limited set of words. What are those words? Always, passage, begin, if, else, end module. It has got some list of around 200 words. What we call as Verilog language constructs. These 200 words are called as what? Verilog language constructs. Only it will understand. Rest all things it doesn't understand. Then you may say, sometime back you said 50, now you are telling 200. So 50 is what we use day to day. Even in language, Telugu language, there are thousands of words which I don't know. Right? I know only 20% of words in my language. Everyone, right? Your native language only, there will be 80% of words which you probably won't even understand. Same is the case in Verilog also. Out of the whole language, you frequently use only 30%, 30 to 40%. Remaining 50-60% you never use. You don't find a need to use. That 30-40% happens to be the 50 words. What do you see here? Module is one word you will use frequently. Input, output, reg, always, faucet, if, end module. Biggest code you take, a code which will be 1,000 lines also, they will consist of these words. I mean, they will only consist of 50 words frequently used. So that level of description is called as behavioral style, or also called as higher level description. Now, do you understand what is higher level? At high level, you tell if reset is applied, make count equal to 0. Else, count equal to count plus 1. Low level means you tell this AND gate will be there. This is how AND gates are connected. This is flip flop gets this input. Okay. Luckily, you don't have to do this. You develop this code. You have a synthesis tool. You give this as an input. It automatically gives us as a. That is what is. Implement the design behavior using a higher level description language. Convert this description to gate level. What is that concept is called as? Converting is, it is called as synthesis. Do not implement design directly using transistors. Do not start with gates and transistors. Start with what? Higher level. Rather implement using higher level description. Use EDA tool, synthesis tool, to convert this description to gate level and further to transistor level. EDA tools, EDA stands for what? Electronic Design Automation, plays a major role in this process. Okay, if EDA tools were not there, let's say synthesis tool was not there, assume that in this world there was no synthesis tool, then all these mobile phone laptops would not be possible. They were impossible. Without a synthesis tool, we wouldn't have laptop, we wouldn't have mobile phone kind of things. Because synthesis tool is the one which made it possible to convert the Verilog code into gate format, gate level format. What is meant by higher level description? Do you understand? I have already explained what is meant by higher level description. You write more like English, I just told you. Okay. Above code is given as input to synthesis tool, which converts the which will convert it to give equivalent gate level description of the code. Gates can be converted to transistors. That process is called as what? Layout. The person who converts the gate level gates into transistors is the layout. Okay, I was telling you about what is that language is going to. I told you, right? You need a language which will do the high level description. That is where I asked, let's say we ask ourselves a question. Can we use C language? Answer is what? No, we cannot use. Why we can't use? Because there are three requirements in a hardware, three special requirements in a hardware, which C language cannot fulfill. Structure, state and time, and the concept of concurrent process. These three C language cannot fulfill. See, C and C++ are used for implementing software behavior. We can't use them for describing hardware behavior. I have already explained how hardware differs from software. Concept of structure, concept of state and time, concept of concurrent execution process, concept of concurrent running process. Now, then what is Verilog, what is VHDL? It's like two languages which solves the same purpose. Even VHDL can be used for hardware description purpose. Even VHDL is also called as hardware description language. Hence, there is a need for new language with additional features to describe the hardware specific requirements, which C and C++ don't have. Verilog and VHDL are developed for this purpose. Simple difference is Verilog is used in US based companies, VHDL is used in European based. That's the difference. Now everyone is moving to Verilog. Even European based companies are moving to Verilog. I think it's all summary what we have discussed. Now, I was telling you that Verilog language supports all these three concepts. What are those? Concept of structure, time, and the concurrent process. This is how we can define a structure in Verilog. Please read this once. You can define, this is the design name, these are the ports, these are the directions. I can tell clock is the input port, address is the input, read data is an output port, selection is the input. I can give this kind of directions in Verilog, which is not possible in C language. In C language, everything is a function. Everything you develop in C language is what? Functions. You know functions in C, basic idea you have. You write main function. You can write any function. There is no concept like module and declaring the ports in C language. Did everyone understood this concept? Next. Concept of time and state. I'll explain you through a simple example. Do you know the relationship between frequency and time period? What is time period equal to what? 1 divided by frequency. Are you all clear with this? If one clock is running at one hertz frequency, what is the time period? What is the time period of this clock? Tell me. 1 second is the time period of a clock which is running at 1 hertz. Clear? If using this clock, using this one hertz clock, I want to implement traffic light control. What is my requirement? Using this 1 hertz clock, I want to implement traffic light control. 1 hertz translates to how much time period? 1 second. Okay. So if I have red light which runs for 50 seconds, how does the clock look? You know, right? What is time period means? If it is 1 second, tell me what is this distance? It is half second. What will this be? So 1, 2, 3, 4. So what is this distance? Tell me. Time. 3. 1, 2, 3. So in summary, if I have to get 50 seconds time, how many edges I have to count? How many positive edges I have to count? 50 positive edges I have to count. So if I develop a circuit, if we develop a circuit which counts 50 positive edges, then it will mean 50 seconds of delay. Tell me what is this circuit is called as? What is this circuit is called as? This is called as counter, no positive counter. This is the same thing that you learned in digital design. Digital design trainer has taught you some counter, right? These are the counters only that you have discussed. Okay. So what does that counter will do? It counts the positive edges of clock. So in this case, why we are counting only 50? Why we are counting only 50 edges of the clock? Because we are using a 1 hertz frequency, which means 1 second time period. To get 50 seconds, you have to count how many edges? 50 edges. This is how traffic light controller works actually. This is how the traffic light controller actually works also, where it has got a clock. But only thing is, it won't be 1 hertz. It will be bigger frequency. As the frequency goes up, what happens to the time period? It will come down. It will be down, right? Because of inverse relation. As the frequency goes up, time period will be less. As the time period less, you'll have to count more edges. But you got the basic idea how the concept of time works. This is how the concept of time works in every hardware. It can be a simple thing like traffic light controller. Even it could be a complex things like my mobile phone. Let's say right now, my phone is off. I keep a stopper, something. It counts, let's say 1, 2, 3, like that. Even in that, counter is involved. Now, can you please read it? Read both of them. Okay, so have you understood the concept of time and state now? So what is the state there? Traffic light in red state, yellow state, green state is the state. Does it stay red throughout the lifetime? It stays for 50 seconds, then it moves to yellow, then it moves to green. This is specialty of a hardware which software don't need. Verilog has a concept. How Verilog does? Through this concept, it can count the edges. It can check for positive edges, and through that we can count the number of edges. Once you count the edges, you have the time. You know that when you count 10 edges, it means this much time. That's how you can get the concept of time. Coming to concurrent running process, Verilog has a concept of always blocks. If you want 3 processes, you have to use 3 always blocks. There you get 3 concurrent processes. What is always block and how does it translate to a process? We'll discuss. Right now, let's not go deep into it. I'm just trying to help you understand why do we need a new language called as Verilog. So Verilog is used for implementing hardware behavior. Because of that, it's called as hardware description language. It is not called as a programming language. So Verilog is not a programming language. Whereas C and C++ are what? Programming languages, because they are used to develop the software. You understand why we call Verilog as hardware description language? It describes the hardware behavior. Using that language, you tell how mobile phone hardware will behave. That behavior finally converted into mobile phone hardware itself. Any questions so far? Clear, right? So this should have given you a basic background of what is Verilog language and how Verilog language has evolved. So throughout this next 1 month, you have to remember that Verilog is a simple language actually. Okay, if you start with the assumption that it's a very complex thing, it It will be complex. But I have given you the logic why it's simple also. There are only very few things you have to learn in Verilog. We will start with simple concepts like implementing of combinational logic using Verilog. Once we are done with this, we'll go to sequential logic. Then we'll go to designs which involve both combinational logic and sequential logic. So we are going to learn the whole Verilog in 3 stages. Learning how to implement combinational logic. Second, sequential logic. Third, involving all the three, both of them. So as part of this combinational logic implementation, we will implement every combinational logic circuit we studied in digital. Everything. You ask me, will you implement comparator? Yes. Will you implement multiplexer? Yes. Will you implement encoder? Yes. Okay, let's say we do 80%, you should do remaining 20%. You should not have any doubt if someone asks you implement decoder. You should know decoder, this is how it functions. Then you should know this is how Verilog code will look like. Okay, so that is what we are going to do. So this may go for 1 week to 10 days time, but we will complete all those things. So let us start with the implementation of the combination.